In this question, we have this diagram, which is a circle, and we have an arbitrary point P whose coordinates are x, y, and that implies that if we draw a triangle here, this will be y, that will be x, and that will be the radius r. Okay, such that any point on the circle formed at any point P on the circle, the coordinates will be x, y. Okay, so moving on, so we have this condition that let m be equal to tan x sine y over r, and it's also given that the rate of change of y is equals to 0.001 r for part A, and you are required to show that the rate of change of m is given by that expression. So one thing that you need to keep in mind here is that m here represents the gradient of OP. So note that m represents the gradient of OP. Yeah, OP is this line here. Yeah. So basically, dm over dt is the rate of change of the gradient. Okay. So moving on, how can we be able to find the rate of change of gradient? Well, we can think about a chain rule, and previously I discussed that dm over dt can be, the connection between these variables can be expressed this way using chain rule. Dm over dt can be equal to dm over dy multiplied by dy over dt. Now we can notice here that this is actually given, yeah, in the question, and basically dm over dt is what's required. Okay, so we can find dm over dy by differentiating this equation implicitly. Yeah, so basically by differentiating this equation implicitly, we'll end up with d over dy, because you are differentiating with respect to y, of m will be equal to d over dy of tan arc sine y over r. Now here we can apply chain rule, so we differentiate outside and inside, so the derivative of this will be equal to secant of what is inside squared, and what is inside is basically arc sine y over r, so arc sine y over r, and then multiply by the derivative of y over r will just be first of all the derivative of arc sine y over r, so arc sine. Now remember here we're applying chain rule 3 times for tan, arc sine, and y over r. So for tan we have this secant of whatever is inside squared. For the derivative of arc sine, that will be equal to 1 over the square root of 1 minus x squared, and our x is y over r, so y over r squared multiplied by now the derivative of y over r will be equal to 1 over r because you are differentiating with respect to y. So it means that dm over dy will be equal to, as we can see, um, so this is the same as 1 over cosine of this squared, so cosine of arc sine y over r, and then oops, let me just, this should be here, and then multiplied by, we can multiply these two together, so we'll have 1 over r multiplied by the square root of 1 minus y over r squared. Okay, so now what I want to do here is, let's think about this triangle here. Yeah, I want you to think about this triangle here because I want to use it to try and do some analysis. So if you consider that triangle here, so from the diagram, we can notice that sine theta, so sine theta is equal to y over r, which implies that theta is equal to arc sine y over r. And also we can notice that cosine of theta is equal to x over r, which implies that cosine of theta squared will be x squared over r squared. Okay, now keeping that in mind, these two statements, that implies that, so this implies that the cosine of theta, and theta basically represents that, yeah, so cosine of theta squared will be equal to x squared over r squared. So this implies that cosine of theta, but theta is arc sine y over r, yeah, squared, will be equal to x squared over r squared. So that's very, very important. So what does that mean? It basically means that instead of writing all that, yeah, I can just write that because this is the same as that. So that will mean that our dm over dy from here, so dm over dy will be equal to 1 over x squared over r squared multiplied by 1 over r multiplied by the square root of 1 minus y over r squared. Now this can be written as r squared over x squared multiplied by 1 over. Now what we can do here is, inside the square root we can factorize 1 over r squared outside, so we'll end up with r squared minus y squared if we factorize r squared outside. So the resulting expression will be r squared over x squared multiplied by now another thing that I can do here is factorize out, I mean, if you take the square root of each of these independently, the square root of 1 over r squared will just be 1 over r. but now the square root of r squared minus y squared will just be r squared minus y squared. Okay, so that will mean that dy dm over dy will be equal to so these two cancel, so that will be r squared over x squared multiplied by 1 over square root of r squared minus y squared. But we know that again from the diagram above here by Pythagoras theorem, if you look up here, we can see that x will be equal to the square root of r squared minus y squared. Yeah, so basically x here is basically the square root of so which means if x is equal to that, so x squared will be equal to r squared minus y squared, and this is by Pythagoras theorem. So basically in our expression here we can write this as r squared over, now instead of x squared we can write r squared minus y squared, and this will be multiplied by 1 over square root of r squared minus y squared. Okay, so and we can put these two things together, because we have r squared minus, this is, let's say this is 2 power 1 and this is 2 power half. In fact, we can write it this way: this is same as 2 power 1, and this is same as 2 power a half. And if you apply your laws of indices, this will be equal to r squared over r squared minus y squared to power 3 over 2. Okay, and you can even simplify this further. So just simplifying this further, this can be written as let's leave it for now like that. Anyway, so dm over dy is equal to that. So what we want to do is we want to find dm over dt. What we have is dm over dy, and that is given in the question. So basically dm over dt will be equal to dm over dy, which is r squared over r squared minus y squared to power 3 over 2 multiplied by dy over dt, which is given as 0.001 r. So this is multiplied by 0.001 r. Now if we multiply these two, we shall end up with now this is the same as dividing by 1,000. Yeah, multiplying by 0.001 is same as multiplying by 1,000. So we can write this as r cubed over 10 cubed, yeah, multiplied by r squared minus y squared to power 3 over 2. And this can be written as r over 10 basically into bracket r squared minus y squared to power a half, all this to power 3, because if you expand you'll end up with 10 to power 3, r to power 3, and this to power 3 over 2, which is basically what we have here. But this can be rewritten as r over 10 into bracket, or square root square root of r squared minus y squared, because that's same as 2 power half, all these 2 power 3. And I believe that is what is required of us in this question. So that's part A. So that's basically how to work out part A of this question. Now for part B of this question, we are just required to interpolate the rate of change of the gradients. So dm, that's the easy part. So dm over dt is the rate of change of the gradient of line OP. So this is the rate of change of gradient of line OP. And that's it.